Okay, good. Hey, my name is Jelmer Sanders. I am the product manager for linear LED modules, also referred to as indoor modules. And thank you for the opportunity to present some of the developments in this field. Um, so I, due to the time, prefer not to talk too much about the individual products which we have, but I would prefer to talk about a few of the trends we see in indoor lighting, especially related to the light engines and the light modules. So we all know that 10 years ago, when LEDs became the big thing in lighting, we all wanted to have big energy savings versus fluorescent and other light sources, and we definitely got those energy savings. But to be very honest, the efficiency improvement of LEDs is at its almost natural end. So it's getting much harder to get a higher lumen per watt based on the same other specifications of light sources. So the comparable efficiency gain is becoming much less. On module level, we are now typically at around 180 lumens per watt for the biggest part of our portfolio. There is the very high statement portfolio, which can go up till 200 lumen per watt. And we have, of course, an economy portfolio, which remains at around 160 lumens per watt. But in the coming years, there is no expectation of a big breakthrough that we can, again, achieve another 15 or 20% efficiency. On the other hand, there are very exciting things going on in this industry and in this market. So because of LED, we still have a lot of new possibilities. For instance, CRI 90, high efficiency, still a bit related to efficiency, but typically in office applications, we use CRI 80. And we can now improve to a better color rendering with our CRI 90 products. In the past, you had 17% efficiency drop if you moved from CRI 80 to CRI 90. And now, with our latest technology, that drop is less than 5%. So now it becomes really accessible also for office applications or retail applications to invest in a CRI 90 solution because the energy efficiency is almost on par with a CRI 80 solution. Then FlexTune tunable white, Wojciech already presented something on our drivers in that field that we're heavily focusing on that, but also on the modules, we have some fantastic new opportunities. Tunable white itself is not new, but with LED, we have the opportunity now to have a better efficiency, even have a better efficiency on CRI 90 products, same as the previous bullet point, the CRI 90 high efficiency. We can also do that in tunable white. But we also have the opportunity to put the color mixing inside the LED. So if you look into the luminaire, you do not see two different color temperatures anymore, which mix into one common color temperature. No, every single light point, every LED has the same color temperature at any given moment. And that's something new with LEDs. And the last, but definitely not the least, is human-centric lighting. It's the biggest thing in light sources in the coming few years, where a lot of investments are going on and where we are launching a lot of exciting new products. So moving there, the rest of my presentation will be fully about that last bullet point of human-centric lighting, because it's really important to us people. Because just like food, we actually need light to nourish our health and well-being. And we see it as you need light to see better, function better, and feel better. And how do we do that? So see better, I think we're all familiar with. This is really the part everybody in the lighting industry is talking about for many years already. So how much lux do we have on desk level? How is the task area lit up? So you need to have 500 lux on your desk. Then feel better, we often refer to as luminance. We also know that. So how is the UGR? Are you not looking into the light source, or is the reflection on your screen in your eye not comfortable? But the middle part, the third one, function better, is something pretty new in the field. And that has to do with the, here it already says that melanopic equivalent daylight illuminance, the MADI. How much vertical lux do you have on eye level? So instead of measuring the light on your task area, we're going to measure the light on eye level. And I'm going to explain you why. So what is human-centric lighting? In our view, it's electrical light that has been enhanced to bring the benefits of natural daylight into the indoor environment. So that's a very nice sentence, and due to time, I will not go into too much detail and immediately explain how it works. So we look at three typical aspects of light: visual, emotional, and biological. Starting with visual, it's about see better. So the quality of light, color rendering index, the CRI. So what is how good are the colors being represented by the light source? What is the R9 value, the flicker, the glare? So we look at illuminance at the task level and the luminance. Emotional is feel better. So we want to bring the outdoor experience indoors by adding dynamics, like with flex tune, tunable white technology. You can bring that experience indoors and also mix certain colors to represent certain times of day. And function better. So sleep well, stay alert, and be healthy. And we can do that by tuning the spectrum of the light, talking about illuminance at eye level instead of at task level, and for a certain time and duration. And this all goes back to biological light. And what is now biological light? Because basically, if you go into the theory of lighting, of biological light, we need to go back to before 1800. Before 1800, we were living mostly outdoors. Outdoors, on a nice sunny day, you have around 100,000 lux. On a cloudy day, so today in the Netherlands here, it's pretty clouded, it's still 10,000 lux. But what do we have in a regular office? Our norms and regulations say that we need 500 lux in the office. So can you imagine that we are actually, our bodies are used to being in very high light levels during the day, 10 to 100,000 lux, and we are staying 90% of our times indoors, since the Industrial Revolution that even became more and more, and we're only getting 500 lux or even less to live in. So maybe this one still. You see that also the light level outdoors varies during the day. So you have a very low light level in the morning, then it grows fast in the morning, in the afternoon, up till at least 10,000 lux, but on a sunny day even higher. And then in the evening it drops again to below 10 lux. So this is important to remember, that we really have that low level during the morning and the night, and that high level of light during the day. And this is impacting our circadian rhythm. In 2002, the researchers found that we have an IPRGC receptor in the eye, often referred to as the third receptor. And this is regulating our sleep pattern, the hormone creation of melatonin. And in a very short nutshell, basically, natural light, when the sun goes down, light level goes down, your body is being triggered by that IPRGC receptor to start creating melatonin. A few hours later, you feel tired and fall asleep. In the morning, light level starts to increase again. IPRGC receptor is again being triggered. There is light, and there is the right amount of light and the right spectrum. So I need to suppress the creation of melatonin. So I'm active during the day. That's basically in a nutshell how it works. And this is referred to or linked to the dark light cycle. But we are influencing that by not being outdoors, but being indoors. Instead of being in 10,000 lux, only in 500 lux. Also, we are working on the wrong, or in the wrong light spectrums, I should say. This is daylight at 6,500 Kelvin, which is pretty long times during the day. It's represented by this light spectrum. And that IPRGC receptor is especially sensitive for the light around 480 nanometers. And this is what we call the melanopsin curve. And this is basically activating our circadian rhythm or disturbing it. So what are we now doing with our bodies? We are actually having too much light during the morning and the evening, because at home in our places, it's not lower than 10 lux. It is probably somewhere between 50 and 100 lux. But during the day, we are not at 10,000 lux. No, in the office, if you're lucky, you're at 500 lux. In our schools, we even only have 300 lux. So we're having too much light when we do not need light, and we have not enough light when we do. And that's actually shifting our circadian rhythm, making you feel sleepy when you don't need to be sleepy, and letting you stay awake when you actually need to sleep. And due to time, I will not go too much into detail, but basically what we need is more biological active light instead of regular electrical light. And this again explains 300 lux at schools, 500 lux in offices. This is what we call biological darkness. So basically, because we're so much indoors, we say that we are living in biological darkness. That not alone, we're also having the wrong spectrum of the light, because I explained we need 480 nanometers, but that's exactly the part of the spectrum in regular 4000 Kelvin daylight or office lighting is being missed because it's not so efficient. So it's filtered out typically. And that's something that we are changing with our solutions. So we are having a solution, and our partners at Gaash can tell you a lot about that. But we have a solution there. We fill this 480 nanometer peak with cyan light, so that even at 500 lux, that IPRGC receptor is still being triggered during the day. So it's really an office lighting solution. And that's related to the melanopic daylight equivalent ratio, the MDARE. So it has a very high MDARE performance. And with that, if you also refer to well building certification, this is a very easy way to score a lot of points without having a very complicated system, because we do change that spectrum of the light in order to activate the IPRGC. So we create a lot of melanopic lux, as we call it. So a lot of lux on eye level with the right spectrum. So that leads to a very high MADI. And this is, again, the point which is being measured in the well building certification, where typically you need around 160 MADI, and in a standard office application, you get to around 100 or 120 maybe. And with our solutions, which you can refer to the people of Gaash, you can easily get there without having too much to change in the office or increase the light levels. So in a nutshell, biological light is important, and external scientific research, so not our research, but really researchers from very well-known universities, found that there's effects of, if you do not have enough biological light, the effects are on disturbance of the circadian rhythm, and there is an increased risk of tiredness or fatigue and sleep disorders. And there's also being worked on publications where the lack of light leads to an increased risk of diabetes, cardiovascular disease, mood disorders, and even cancers. So it's really important that we as an industry take the steps to improve the light quality in the indoor applications. Any questions? No? No. Then I will stay online, so if there's any questions later on, feel free to ask or reach out to the people at Gaash or to Luca. Thank you.